Hello everyone. This is Gayatri Priya, Assistant Professor in the Department of ECE of R&D Engineering College. In today's session of Analog Electronics, we are just going to discuss about differential amplifier. So what is a differential amplifier? So as the name indicates, right, the differential amplifier is a DC coupled amplifier. So that is, it is going to amplify the difference between the applied to input signal. This is going to be the basic building block for almost all our integrated circuits and operational amplifier. Since it is having a very good noise immunity, we are utilizing this differential amplifier to a greater extent. If you look at this block, V1 and V2 are going to be the input voltage and the output voltage is going to be the difference of the input voltage. If V1 is greater than V2 or V2 is greater than V1, whatever it might be, the difference of the input voltage will be amplified over here. This is the block diagram of a simple differential amplifier, right? So as I told already, we can feed both the input at the same time or one at a time, right? In first case, this is called dual input, whereas the second case, it is going to be a single input. Right? So if the output is taken from one terminal, then it is called unbalanced output. If we're going to take the output from the terminals of two transistors, then that is called balanced output. So this is a BJT differential pair. Okay, here we are having two transistors Q1 and Q2. Okay, so and this is the connected in common emitter configuration with a constant current source of IQ. The other end is connected to V minus, and whereas the collector is connected to V plus, exact opposite to that. This is VB1 and VB2. Therefore, the current flowing is IE1, IE2. The base emitter junction voltage VB1, VB2, current IC1, IC2. Almost everything is going to resemble the same. Right? So what happens here in the sense, we are assuming always the Q1 and Q2 are driven in the forward active region. So as a result, the output resistance are almost negligible, right? So here we are using both the positive circuits as well as the negative supplies. Here we are collector, we are giving a V positive, whereas at the emitter we are giving a V negative. Therefore, no need to connect any coupling capacitors, or it is not mandatory to connect the circuit only in the voltage divider bias. The stability is already achieved by applying a positive as well as the negative bias voltage, right? So we know already the common emitter voltage can be of the order of cut-in voltage, that is 0.7 volt. Okay, so the difference is going to be get amplified, right? So what are the various configurations of differential amplifier? So as we are told already, if I am going to apply the input at both the base terminal V1 and V2, and we are going to extract the output from both the collector terminal, it is called dual input balanced output differential amplifier. Coming up for the next circuit, here we are applying two input at both the base terminal, but the output is taken only from the collector of your second transistor. Therefore, this is unbalanced output. Dual input, unbalanced output differential amplifier. Coming to the third configuration, right? Here we could see we are applying the input only to the base of first transistor alone. The second transistor base is directly grounded, that is, it is at zero potential, but the output is taken across both the collector. Therefore, this is an example for single input balanced output differential amplifier. Obviously, the last one is going to be single input unbalanced output differential amplifier. So these are the two modes of operation of a differential amplifier. One is common mode, the other one is differential mode. So common mode, in the sense we could see, here we are going to apply the same amount of voltages. Here it is going to be VQ minus IQ by 2 RC, the same here also as the output voltage. That is, we are just making both the base terminal connect at one point, and a common voltage VCM is being given up here. This is for common mode configuration, whereas this is for differential mode. So in this differential mode, here we are having Vd by 2. Here it is going to be negative Vd by 2. Okay, thereby forming the differential mode of operation. Right? So obviously the output will be showing a difference, the same amount of difference but in the opposite direction. This is plus del I and this is going to be minus del I. Right? So this is the differential mode gain, ratio of output voltage divided by difference between the input voltages. Whereas the common mode gain is going to be V0 by Vc, where Vc is the average of the input voltages. And this is CMRR, common mode rejection ratio, ratio of AD to ACM, right? So this is the most important thing, how much amount of common mode signal is going to be present, how much amount we are going to eliminate, that is being determined by this CMRR. So generally ACM is 0, whereas where AD is going to be infinite in nature, right? So these are the few applications of differential amplifier: automatic gain control, volume control, amplitude modulation, servo control, analog multiplay. Hope you understand this session. Thank you.